Okay, so for the warm-up, we should have plotted all 6 of these points. A is at 3, 2, so we should have moved to the right 3 and then up 2 units from the middle. So this should have been A. B should have been at negative 5, 1, so move to the left 5 units and then up 1. So this should have been the coordinate for B. 3 should have been plotted at 0, 3, so 0 units left to right, 3 units up, so that would have been C. And then D would have been to the left 1 and then down 4, so there should have been D. E should have been to the left 3, no movement vertically. And then F should have been 2 units to the right and then down 1. That was F and that was E. Okay, moving on. So this is chapter 3. This is lesson 3.1 involving functions. We're going to talk about what a function is and what it looks like as a graph. All right, this was an adorable little child that I added to the slide. He's pretty cute. Let's put the fun in a function. Okay, how does this apply to me? Guys, this lesson is super important because we're going to learn how to interpret a graph and also how to create one ourselves. We're also going to talk about exactly what a function is, what defines a function, and why functions are important. Okay. Determining whether relations are functions, okay? A relation is a pair's inputs with outputs. When a relation is given as an ordered pair, the x coordinates are inputs and the y coordinates are outputs. A relation that pairs each input with exactly one output is called a function. So if we take a look at A, B, C, and D, A has a collection of points. It says negative 2, 2, negative 1, 2, 0, 2, 1, 0, and 2, 0. And it wants us to determine whether that relationship is a function. How we determine that is we have to look only at the inputs. Negative 2, negative 1, 0, 1, and 2. As long as each input is not being used twice. So as long as each input is being used only once, you've got a function. In this case, we have a function. Now, take a look at the second example. In the second example, we have 4, 8, 6, 4, and 5. The number that's repeated is the 4, so we do not have a function, okay? There is not a function there. Okay? Because the definition of a function says that each input has to pair with exactly one output. In this case, the 4 is paired with the 0 as an output and also with the 3, okay? Now, outputs can be repeated like they were in A. Do you see how 2 was used as an output once, twice, 3 times, and 0 was used as an output twice? Outputs are okay to be repeated. They can still be a function. But when an input is repeated, it is not a function. Take a look at C. We've got 0 and 0 being used twice. The first one goes to 5, the second one goes to 6. This is not a function. And now let's look at D. We've got the inputs of negative 1, 3, and 11, and they correspond to 4 and 15 for both 3 and 11. Remember, even though our output 15 is being used twice, all of our inputs are different, so this is also a function. Okay, and let's do a few more examples. So let's take a look at these. In the first one, this would not be a function because the 5s are repeated, so not a function. The second one, we can say that it is a function because the negative 4, the negative 1, the 2, and the 5 are all different values. In the third one, we can say that this is a function because 2, 4, and 6 are all different values. And in the fourth one, we would say this is not a function because 1/2 is the only input and it's being used for 3 different outputs, okay? So 1/2 is being used more than once as an input. Okay, there is something called the vertical line test, and the vertical line test is a graph. A graph represents a function when no vertical line passes through more than one point on the graph. So if you take a vertical line of a function, or into any function, it should cross that function at only one time. So look at the example on the left. If we were to draw vertical lines at each of these dots, they would only hit the graph at the blue dot. They don't intersect more than that line, than that point, okay? So this would be considered a function. Now, over on the graph on the right, if at any time you draw a vertical line and it passes through the graph at more than one point, in this case we've drawn two vertical lines that cross through it more than one point, that would be considered not a function, okay? So as long as you pass the vertical line test, you have a function, but if you don't, then you do not have a function. Let's try some examples. So in the first example, in A, there are two lines that we could draw that would create this to be not a function. The first one's at 2, and the second one is at 5, okay? Now, it crosses our graph at 2 points, and this one crosses our graph at 2 points. So this one is not a function. Let's check out B. Now B, doesn't matter where we draw this vertical line, it's going to be a function, okay? The vertical lines are all going to intersect only at 1 point each, okay? If they intersected more than once, or once, twice or more, then it would not be a function. But in this case, it is a function. Okay, now something really cool to notice. Go back to A. Let's look at what the coordinates are of the points that cause this not to be a function. Well, the coordinate up here is 2, 5. The coordinate down here is 2, 2. The coordinate over here is 5, 5. And the coordinate over here is 5, 1. Now, if we use the same logic that we used in the previous examples, notice the input is being used more than once. So anytime your input is being used more than once, you don't have a function. That is exactly what the vertical line test is testing for. It's saying, okay, along all the vertical lines, does the graph have more than one solution? And in this case, it does. It has two solutions, both at when our input is 5 and when our input is 2, okay? Let's do one more example, or a few more examples. Number 5, this one definitely passes the vertical line test. We can say that it is a function. Number 6, if you were to draw any vertical line on this graph, it would only intersect the graph at exactly 1 point. So if we check out all these vertical lines I just drew, 1 point, 1 point, 1 point, and 1 point, okay? So this one is also a function. Okay, let's keep looking. Number 7, draw just any generic dotted line down the middle. 2 points of intersection, not a function. Number 8, we've got a V-looking graph, but even though it looks weird, we still can draw vertical lines down the graph, and they all intersect at only 1 point. So this one is also a function. Okay, so now we're going to talk a little bit about domain and range. The domain of a function is the set of all possible input values, and the range of a function is the set of all possible output values. You can think of a function as like a machine. It has input values, which would be your domain. And then it also has output values, which you would consider as your range. So whatever you input into the function as part of your domain, the output, which would be, in this case, our input is X, our output is Y, that would be our range. Okay, let's find the domain and range from a graph, okay? So in A, we are finding that what the domain and what the range is. The domain of A is all the values that X could be. Well, there's a point here, a point here, a point here, and a point here. There's 4 points. So there's going to be 4 domain values. The first value I see is at -3. This point is at -3, comma, -2. This point is at -1, comma, 0. This point is at 1, comma, 2. And this point is at 3, comma, 4. So our domain is all of the x values that we just found. In other words, -3, -1, 1, and 3. Those are all the values that x could be. Those are our inputs. Our outputs are what y is, -2, 0, 2, and 4. That's our range. So our range in this case is -2, comma, 0, comma, 2, comma, 4. So we've got all our domains, all of our ranges, and they have to be, write this down as a little note to yourself, they have to be ordered from least to greatest. Okay, the next example, which is B, okay? In B, all you gotta do is figure out, okay, what are the smallest values that x could be? And what are the biggest values that x could be? Well, the smallest value that x could be is right here at -3. The biggest, at -2. The biggest value that x could be is right here at +3. So our domain is going to look a little different. The reason our domain is going to look different is because these were points. These were specific instances in time. So our domain was a set of numbers. Now our domain could be anything between -2 and 3. So how we write that is with an inequality. We write it with an and inequality. So we're going to write it as -2 as the smallest value. X can lie anywhere above -2, but it also has to be less than or equal to +3. Okay? Now let's think of the range. Our range are all the restrictions on our y values. Well, the smallest y value that I see happens right here at -1. So we know that our range, y needs to be bigger than or equal to -1, and it can go all the way up to +2. So it needs to be less than or equal to +2. So we've got our domain and range defined by an inequality. Okay, last thing, guys, dependent versus independent variables. An independent variable is a variable that is, it's the one that's your input, okay? So in 99.9% of the cases, your independent variable, when we're relating x and y, will be x, okay? Your dependent variable is, it depends on the input value or your independent variable. So that is called your dependent variable, and that is your output, okay? So in 99% of the cases, y will be your dependent variable, okay? So let's identify independent versus dependent variables. In the function y equals -3x plus 12, our function is doing this, and our input values would be x. Our input values would be x. Our output is going to be what's over here on the other side. This is our output, and that will be y. So in other words, y is going to be our dependent variable. And x will be the independent variable. Or our input. And then y is our output. Okay, now we are given the domain. In other words, we're given the values for x, and we have to figure out what the range is going to be, okay? So what we're going to do is we're going to take this domain, and we're going to find out what each of the y values are at that domain. So we're going to figure out, okay, what is, when x equals 0, what is y? Well, y is going to be -3 times 0 plus 12. So y equals 0 plus 12, y equals 12. So our range starts at 12. Let's see what happens when x equals 1. Y equals negative 3 times 1 plus 12. All I'm doing is I'm taking these values from my domain and I'm plugging them in to my original equation, which was y equals negative 3x plus 12. Okay, so we got y equals negative 3 plus 12, y equals 9. We keep going, x equals 2. Y equals negative 3 times 2, times 2 plus 12, y equals negative 6 plus 12, y equals positive 6. So we've got 12, we got 9, we got 6. We've got 2 more, x equals 3 and x equals 4. X equals 3. Y equals negative 3 times 3 plus 12. Y equals negative 9 plus 12. Y equals positive 3. Okay, we keep going. X equals 4. Y equals negative 3. Oops, I forgot to change this one. This should be a red 3 times 4 plus 12. Y equals negative 12 plus 12. Y equals 0. Okay, so our range is now all of these values that I just computed. 12, 9, 6, 3, and 0. Now, again, your range must be organized from least to greatest. So our range, in this case, is going to be 0, 3, 6, 9, 12. And that's it.